Hello, and welcome to the Software Engineering Institute's webinar series. My name is Shane McGraw, your moderator for today, and I'd like to thank you all for attending today's webinar. Our webinar series presentation today is the Source Code Analysis Laboratory, or SCALE, by Robert Secord. Robert C. Secord is a computer security specialist and writer. He is the author of books on computer security, legacy system modernization, and component-based software engineering. Robert manages the Secure Coding Initiative at CERT, located in Carnegie Mellon's Software Engineering Institute in Pittsburgh, Pennsylvania. CERT, among other security-related activity, regularly analyzes software vulnerability reports and assesses the risk to the Internet and other critical infrastructure. Robert is an adjunct professor in the Carnegie Mellon School of Computer Science and in the Information Networking Institute. Now, before I turn it over to Robert, we want to ask a quick polling question to get an idea of who is in the audience with us today. And that question is, to what extent has your organization adopted one or more of the CERT Secure Coding Standards? We'll take about 15 or 20 seconds to vote here, and then we can share the results with our speaker, and we'll pass it on to him. Okay, we'll push the results here. We're looking at 63.2% with not at all, Robert. About 4.4 have adopted as corporate standard. 16.1% required by some projects, and 16.1% also using on a trial basis. So we will now turn it over to Robert Secord. Robert, all yours.
Thanks, Shane. So those are pretty interesting results. I know, for example, that Cisco has adopted our CERT C Secure Coding Standard, and more recently, Oracle has adopted all of our coding standards. So this first slide shows the number of vulnerabilities that have been reported over a 7-year period. This is one of the typical hockey stick charts where the number of reported vulnerabilities has been geometrically increasing. This chart can be used for various purposes. My tendency is to use this to point out that whatever it is we've been doing for software security for the last 20 years or so apparently isn't working, because otherwise you'd expect that curve to level off and maybe start to come down. So when we talk about application security, we don't really mean necessarily the authentication and identification mechanisms. We're talking more about the quality and correctness of the software. So there's this photo that I found on someone's blog some years ago, but it shows this very nice gate mechanism that I'm sure the owner of this facility paid a lot of money for, and I'm sure the gate works very well. And it prevents, it allows authorized users access to the facility, and it prevents unauthorized users from passing through the gate. So the problem isn't the gate so much as all the tire tracks running through the field. And that sort of represents a typical software system and coding errors in the code and vulnerabilities that allow attackers to bypass the security mechanism and gain access to the facility, following basically the easiest path, the weakest link in the defense. So this talk is kind of split into two parts. I'm going to do some technical stuff in the beginning, and then I'm going to step back and talk more about our coding standards and scale. The specific problem I was going to describe today deals with compiler writers that are increasingly taking advantage of undefined behaviors in C and C++ programming language to improve optimizations. So the problem with these optimizations is that they can interfere with the ability of developers to perform cause-effect analysis on their source code, meaning that it's become increasingly difficult for programmers to look at code and understand what that code is doing. And similarly, it's difficult for automated analysis tools to look at source code and understand what that code is doing. So these optimizations tend to eliminate causality in software, and that increases the probability of software faults, defects and vulnerabilities in deployed software.